All right, we are going to continue with the orthocenter. Remember the last part of this video we talked about the centroid. Now we're going to kind of go a little deeper into the orthocenter. Just as a reminder, this is the point of concurrency of our altitudes, and when you think of altitudes, I always think of like maybe the Smoky Mountains. We're going up high, the height at which we are at, maybe in an airplane, and that's kind of what the altitude is. It's kind of the height of that triangle. So when you are doing these heights, remember, maybe you can remember that. Another reminder is the altitudes go from the vertex perpendicular to the opposite side. Now, depending on your triangle will depend on where that perpendicular part is, but it doesn't necessarily always go through the midpoint, so we do have to remember that as well. And then that point of concurrency right there, point P, is called our orthocenter. Now we are going to go through a little bit of a lesson on where is the orthocenter depending on what type of triangle you have. So you will need a ruler in hand, and you will need a few different colors because it'll make it a little bit easier. We are wanting to see where does each altitude intersect in a triangle. So remember, we need to go to from the vertex to the opposite side. Now, this sometimes can get a little confusing if you don't necessarily have a couple different colors. So notice that I have my vertex and I'm going to the opposite side, and I want to be perpendicular. So notice this side actually kind of comes down to be that side of the triangle. Now I'm going to erase that just so it doesn't get too confusing. I'm next going to go from my vertex, and notice my opposite side is going to be this right here. So I need to be perpendicular, and you might have to kind of turn your iPad or your paper to the side to create that. So I'm just going to be perpendicular using that tool of your ruler. And then my last ortho, or my last altitude, I'm going to go from this vertex and then to the opposite side. And I'm just going to kind of dot this one because I don't necessarily want you to think it's the line. So from the vertex to that dotted line. And notice where my orthocenter is. It's actually on the triangle, which is on the vertex at a right angle. Okay, let's move over here to the acute triangle and see if we can continue to kind of grasp this concept. So I'm going to go from each vertex, and I'm going to go to that opposite side. I'm going to just kind of dot it so we know where we're going. Sometimes I get a little bit confused because there's so many lines going in every which way, so that's kind of how I keep everything straight, is by color. So I'm going to draw, that. Altitude right there, making sure that it's perpendicular to the side. Then I'm going to go from this vertex to the opposite side. And then the last, if you notice, it's kind of starting to take shape from the vertex to the opposite side, making sure each of those is as close to perpendicular as possible. And as close to perpendicular as possible. Notice that if it's an acute triangle, that orthocenter is actually inside our triangle. Alright, I will say the obtuse triangle is fun, but it can get a little confusing. So make sure you have 3 colors of pens ready. So I need to go from this vertex, and notice I need to be perpendicular, so I need to be straight down, but any way I move my ruler, I'm not necessarily drawing any lines inside the triangle that are perpendicular. So what you need to do is you need to recognize your opposite side. So here's the opposite side. Let me get a little closer. Here's the opposite side to that vertex. And I'm going to draw all the way across, and then when I get ready to get outside of that, I'm going to kind of do a little bit of dot marking. And no, that's not for decoration. It's just to let me know this is not a line that I need to be worried about. All right, so next I'm going to take my ruler and get perpendicular, and then I need to, and this is really the only one we'll have to do this for, I need to extend my line down through that line, and I might even want to, don't worry about that writing right now, I need to maybe extend my line a little further than what I expect. All right, I'm going to go back up here, I'm going to do it again, so I'm going to go from this vertex this time. Notice my opposite side is right over here, so I'm going to do the same exact thing where I'm going to draw a heavy mark, but remember I need to extend it out, and I'm extending it out to the side where that obtuse angle is. So next I need to get perpendicular to that side from my point. So I'm going to go ahead and do that, draw it straight down, and then remember I have to continue that line. So be as close to perfect as you can. And the nice thing is we don't have to use so much eraser anymore. Alright, so notice there is another perpendicular line, another altitude, and last, I need to go from that vertex to the opposite side over here. It's going to be perpendicular, and if you are super accurate, sometimes I get off a little bit, so I have to go back and check myself. If you are super accurate, notice that all three of those lines actually come to a point out here of our orthocenter. So in an obtuse triangle, my orthocenter is going to be outside my triangle. And you can also remind yourself it's going to be below or around, or whatever you want to say, below the obtuse angle. So really that's saying it's not this way of my triangle, it's actually below it. So if you are just in geometry, you can stop now. If you are in honors geometry, we're going to keep on trucking along, figuring out how do we find an orthocenter in a coordinate plane. So there's a few steps that we will take, and we'll do it actually twice, and then we will actually solve a system of equations. So the vertices of our triangle are 1, 2, negative 3, 3, and negative 5, 1. We need to find the coordinates of the orthocenter. Remember, orthocenter, we're talking about perpendicular, so we might, hint, hint, have to find the perpendicular slope. So here are my really 5 steps in solving these types of problems. You only have to do this twice. You don't have to find all 3 altitudes. Just finding 2 will be good enough. We first need to find the slope of one of the sides of the triangle. So you can pick whichever side you want. Maybe we pick HI. And then we need to find the slope of HI. So we can say HI slope negative 3, negative 2 over negative 3, negative 1. My slope can be negative 5 over negative 4, which gives me a slope of 5/4. My next step is to find the perpendicular slope to that. So remember, I'm going to flip it and change its sign. So I'm going to flip it to 4 over 5, changing its sign to negative 4/5. Now remember, we're trying to find the orthocenter, aka trying to find the altitude. So we need to use the opposite vertex. So we need to use J being negative 5, 1, and our new perpendicular slope, which we just found to be negative 4 over 5. Because we have a point and because we have a slope, now we can write our equation through point J that will allow us to be perpendicular to HI. So we can say y minus y1 equals my m times x minus x1. When you solve that equation, you're going to get y equals negative 4/5 x minus 3. Once you have that equation, I want you to stop this video, go ahead and graph this line for you. All right, so you have just graphed your first altitude. Exciting. Now you're going to repeat these same steps, and I would like you to do it from point H to your opposite side JI. So I'm going to stop this video, and I would like you to go ahead and write your equation of the line perpendicular to JI through point H. All right, so after finding that linear equation perpendicular to JI through point H, what I came up with was y equals 1/2 x plus 1/2. So, or 1 1/2. So when I come up here, I graphed my navy blue line, and notice you can kind of see what formed is your orthocenter. So now we need to find that point of intersection. Now, it's not so nice when they don't land on that for sure point, but we know we can solve systems of equations by setting these two equations equal to each other and solving for x and y. So the first thing we need to do is set those two equations. Because they're both set equal to y, we can set them equal to each other. So negative 4/5 x minus 3 equals 1/2 x plus 1.5. All right, go ahead and stop this video and solve for x. All right, after I did my work, I got that x equals negative 3.46, and you can leave it in fractions if you want to. Remember, after you find x, you get to pick which equation. Ooh, skipped up on me. I'm so sorry. You get to pick which equation out of these two you plug it back in for to solve for y. So I'm going to plug it into the top one. So I'm going to say y equals negative 4/5 x, which is negative 3.46 minus 3. And when I solve, I get y equals negative 0.232. So the coordinates of my orthocenter are now negative 3.46 and negative 0.232. All right, I hope this helps. If you have any questions, please feel free to come see me on Monday. Hope to see you again.